An independent editorial analysis of Japan's defense posture and security policy.
The conceptual architecture of Japanese air defense was forged in an era defined by a very specific threat vector: high speed, high altitude, and combat aircraft with a high radar cross-section. This legacy is physically embodied in the Type 81 short-range surface-to-air missile system, a platform that has served as the backbone of the Japan Ground Self-Defense Force anti-access capabilities for over 4 decades. While the system represented a pinnacle of Toshiba electronics and domestic engineering upon its introduction, the contemporary battlefield environment has shifted. We are now seeing saturation attacks by unmanned aerial systems and loitering munitions. This creates a fundamental asymmetry, one that challenges the utility of legacy interception models. The persistence of the Type 81 within the force structure in 2026 serves not merely as an indicator of procurement cycles. It is a case study in the friction between established industrial output and rapidly evolving asymmetrical threats. From a systems engineering perspective, the Type 81 and its upgraded variant rely on a combination of phased array radar for initial acquisition and an optical or infrared homing seeker for terminal guidance. This dual-mode architecture was originally designed to counter heavy electronic countermeasures and maintain a lock on maneuvering jets. However, the proliferation of small, low-cost drones introduces a target profile that the system was never optimized to address. The radar cross-section of a Group 2 or Group 3 unmanned system is often indistinguishable from ground clutter, or even avian biological noise when viewed through the filters of older radar algorithms. Consequently, the reliance on the Type 81 for base defense against modern swarming threats suggests a doctrinal gap. And the sensor resolution appears insufficient to provide the necessary early warning, and the fire control data required for a successful engagement without significant modifications. Beyond the technical limitations of sensor resolution, the economic attrition model presents a more severe strategic constraint. The firing doctrine of the self-defense forces has traditionally prioritized high probability of kill ratios using sophisticated, expensive interceptors. In a scenario involving loitering munitions, the cost exchange ratio becomes unsustainable. Launching a guided missile with an estimated unit cost exceeding 50 million Japanese yen against a disposable drone costing a fraction of that amount represents a financial asymmetry. An adversary can exploit this to exhaust Japanese stockpiles. This creates a situation where the defense force could theoretically achieve a 100% interception rate in the opening hours of a conflict, yet still face strategic defeat due to the rapid depletion of inventory. An inventory that the domestic industrial base cannot replenish in the short term. The rigid production schedules of the Japanese defense industry, which privilege quality and stability over surge capacity, further exacerbate this vulnerability. The modernization efforts, specifically the introduction of the Type 11 short-range surface-to-air missile, address some of these sensor limitations through the use of active radar homing and advanced data links. However, the pace of replacement has been dictated by fiscal constraints and competing priorities, such as the acquisition of standoff capabilities like the Tomahawk and the upgraded Type 12 surface-to-ship missile. This allocation strategy implies that defense planners have accepted a degree of risk in short-range air defense to fund counterstrike capabilities. As a result, the Type 81 remains in service in significant numbers, creating a heterogeneous mix of capabilities where older systems may be forced to confront threats they are ill-equipped to handle. The operational reality is that a significant portion of critical infrastructure and tactical units remains under the umbrella of these legacy systems, creating pockets of vulnerability that a sophisticated adversary could identify and target. Operational constraints are further highlighted by the mobility requirements of the system. The Type 81 typically operates on a 6x6 truck chassis and requires a specific setup sequence to deploy the fire control radar and launchers. In an environment characterized by pervasive surveillance and precision fires, the static nature of the firing unit, once deployed, reduces its survivability. Modern drone warfare emphasizes constant movement, shoot and scoot tactics. The time required to displace a Type 81 unit may exceed the engagement cycle of an enemy loitering munition hunter-killer team. This logistical footprint contrasts sharply with the high mobility requirements of modern expeditionary operations and island defense scenarios in the Nansei Islands. It suggests that the platform is better suited for defending fixed rear area assets rather than supporting dynamic maneuver elements in a contested littoral zone. There is also a dimension of human resource management that intersects with these hardware limitations. The Japan Self-Defense Force faces a chronic recruitment shortfall. Operating labor-intensive legacy systems like the Type 81 requires specialized personnel who must be trained in manual optical tracking techniques. This reliance on the human in the loop for optical tracking, while offering a counter to electronic jamming, places a high cognitive load on the operator. It limits the system to engaging a single target or a very small number of targets simultaneously. Against a swarm attack, where dozens of autonomous vectors converge on a position, the channel capacity of the fire control system and the human operators would likely be saturated almost immediately. This saturation point represents a hard limit on the system's defensive utility, regardless of missile lethality. Discussions within the Ministry of Defense regarding the potential repurposing or transfer of these systems to Southeast Asian partners reflect an awareness of these obsolescence issues. Transferring the Type 81 to nations such as the Philippines or Vietnam would ostensibly serve diplomatic and security cooperation goals. However, such a move introduces complex logistical tales, as the recipient nations would require sustained support for maintenance on a system that is already exiting the primary user's inventory. Furthermore, if the system is deemed ineffective against modern Chinese drone capabilities and Japanese service, its utility to a partner nation facing the same adversary is logically compromised. The transition toward directed energy weapons and high-power microwave systems is often cited as the long-term solution to the drone dilemma. These technologies promise a favorable cost per shot and the ability to engage swarms. Yet the technological maturity and power generation requirements for mobile laser systems mean they are not yet ready for the widespread deployment. This creates a window of vulnerability in the mid-2000s, a transitional period where the old guard is obsolete, but the new guard is not fully operational. Ultimately, the continued presence of the Type 81 in the Japanese inventory serves as a physical manifestation of a transitional friction within the national defense strategy. It highlights the difficulty of pivoting a peacetime military establishment, optimized for high-tech conventional warfare, toward a conflict environment defined by rapid technological adaptation and attrition. The path forward likely involves a hybrid approach, one that integrates legacy kinetic systems with emerging electronic warfare capabilities. Accepting that the goal of air defense must shift from absolute denial to managing the rate of attrition in a complex, multi-domain battle space.